to find out what zone, what UTM zone is Somalia. I plan to give you an exercise where you will have a map of town close to Looks good?
Yes, yes.
So this is my plan. That I will give you an area, a map, and of your area where you will download by downloading DEM for topographic contours. Run arc hydro extension overlay geology there. Develop morphology based on geology. All right. You guys writing all this?
Yes.
Looks good. So the reason that I'm giving you all these exercises is that you should be able to develop a terrain model, develop an overlay, another geology layer, develop a morphological terrain based on your geology and the hydrology of the area, develop a stream network, develop road network, and then run flood modeling and all this. These are all the necessary exercises that you should know in this class. Okay. And in the next advanced class, I will show you how to run the flood assessment model. So using HECRAS and there are other software also. And then how do you do the groundwater modeling? The third step is how do you do the groundwater modeling? And the fourth step is how do you do the how do you run the air pollution model using GIS? These are the 3 and 4 areas that we can develop coursework, but these are some of the basic exercises with your background that you have civil engineering. So this is something that you should know important, that you should know what are the coordinates, how do you do the georeferencing, why do you perform the rectification. There's a ton of material already outside. Our all exercise will be based on ArcGIS. So I wouldn't recommend doing the QGIS thing. If anybody is interested in doing a QGIS, they can do it on their own. But we would like to keep just one platform. So we will just keep ArcGIS and its extensions. All right?
Okay.
Yeah.
Okay.
So my request is that the exercise that we gave you yesterday, the PDF file, I can show you how to. We can run a quick run on this assignment of coordinates today again, and then create digitization. So we'll have because it's a 40-minute session, we cannot have very extended time. So we have already passed 10-15 minutes. कितने रखे हैं हमारे? कितना time है? So we'll come back to this again, and I'm going to do it again. So we use this zoom tool and zoom to this corner, and then use this add control point. Click on this, click at this point.
We have not seen.
We can't see the computer screen.
You can see?
Yeah.
Okay, okay, let me share
Still,
that.
we can see those that notepad.
Okay.
Minimize the notepad.
Okay. You share. Sorry. Now you can see?
Yes, okay. Yeah.
Okay.
All right. So I'm back to this point. I'll do this fast. Okay. I'll do this fast.
Okay.
So you have to just follow. In case if you touch any other area, you can go to this file and delete it. You see the link file. So you have to start the coordinates.
Okay.
So 66 and 25. Unless and until you do it on your own, you cannot learn it. This is a hands-on exercise. Everybody should understand this. So I have given this the part 1, and then I'm zoom out and I zoom in to this point. And I use the tool again, click on this, and then directly at this point, and right click, input, right click, input this 67 point. It's not like that's 30.
67.3.
See, 67.3, now it's showing 67. On your right corner, it's showing 67. And thirty minutes. We are left only with 10 minutes in this session. Yes. Five one is 0.5. 30 minutes, 30 to divide करो 67.5 ये डेसिमल डिग्री है ना सर नहीं 0.5 होगा 0.5 होगा अब मैं यहाँ लेके जा रहा हूँ अब देखिए 67.3 छोटा आ रहा है कौन है 30 minutes is like 30 minutes 1 degree में 30 minutes is half. ये 7.5 लिखेंगे. Then you run, we have done the 4 points and we then rectification, run the rectification. You go to georeferencing, rectify. This is important. So it works. Just hold on. See, it says, in order to rectify, it says cell size and resample time. This is very important. This is very important. See, this is a polynomial interpolation. Resample type, polynomial interpolation. Are you guys with me? Hello?
Yes, yes.
Yeah, when we are under rectification, it gives us option. How do you want to rectify? Do you want to run a nearest neighbor, or you want to run a bilinear interpolation, or you want to do the cubic convolution? These are all polynomial interpolation procedures, methods. So you can select anyone. So we by default is the nearest neighbor, which is for discrete data, which is the most efficient right now. But for more accuracies, we can use the other ones also. But for the practice class session, we are doing the nearest neighbor. So nearest neighbor, the output is being stored in this file. The name of the file is this. You can change the name of the file also. The format is stiff, and the compression you can compress also. I'll just keep it none. So this is the data. This is the cell size. This is something that once we perform we have the 4 coordinates assigned. We will run the rectification tool. So you guys understand what I'm saying?
Yes.
Okay, so now you have an idea. So you say save, and then it create a file. And then you can add. You can add. It has created. Add. Okay. So it has now been added.
Add where? Please.
Add.
Sorry. Can you do the last step? The last step. Add.
Add. वापस remove करके ये div add की ना डाल.
From where?
From where your file was created. This plus, click on the plus sign.
Yeah.
And this, when we were doing the rectify, there was a path that it will be stored here. So I have created a folder, and it gets created in this TIFF file. So I select this, and I add this, and I say OK, and it gets added. It's right there. So this is my JPEG file, original file. This is this file, and these are my. You can click on this, and these are my coordinates. The thing that I assigned, and this is, you see, residual. Under rectification, it does the polynomial. It does the polynomial interpolation, and all the intermediate pixels are assigned coordinate, and this is what it has done in under rectification. So we only assign 4 coordinates, and the remaining part, it does it has done the interpolation. And now you can see, if I move the cursor, you see the cursor. As I move the cursor, you see I'm moving the cursor. You see the cursor?
Yes.
And see this, the coordinates are changing. So everywhere, it's the entire area is now georeferenced. The entire area is now georeferenced. So when you create anything, when you digitize anything, it will be automatically created. Now with using this TIFF file, we will do the digitization. So for example, I want to create a polygon. See this one here. Now I zoom in, and I want to create a polygon of this island. See this island? So first of all, we have only 2 minutes left. So I'm going to open a new section. We will stop here, or just create. We want to create a polygon. This area island is yes. This is a polygon. See, polygon is defined as a closed surface. It has complete closed surface. It starts from here, and closes back to this point. So this is a polygon. So we want to create a polygon, this island, so that we can find out the area of this polygon, this island. You want to find out the area of this island. So how would you do that? We have done the georeferencing, and now we create a polygon. Okay? Got it?
Okay.
So create. So for creation, we click on the catalog. This is the R catalog. Remember R catalog, Mr. Daha.
Yes.
You know what? This is R. You click on R catalog. Click on this. R catalog window gets opened, and then you browse to your directory. Where is your directory? Everybody has his own directory. Mine is C. Is in C drive. S2T works. And this EAU Somalia. Okay, this is my directory. And then right click, new, and shapefile. Click on this. So now it creates a shapefile, assign island 1. Name of the shapefile is island 1. And feature type is, you select the feature type, polygon. And the coordinate system, you assign coordinate system, edit, go to edit and say geographic. So in geographic, you select world, and in world you select WGS 1984, and then it has given the coordinate system, geographic coordinate. It's a global coordinate system. Say okay, and this file now this file gets created.
You see the screen? Seriously, how would you see it?
All right, can you see the screen? Can you see the screen?
Yes.
Hello?
Yes.
Yes.
Yes, yes.
Okay. Okay. So now I have created a polygon shapefile, and now I will start digitization. Attribute. So right click, open the attribute table. Here you add field. All right. So you in this shapefile you want to create a field also. The name of the field is the area. Name of the field is area. You add field. Name of the field is
Island का नाम areas में नहीं कर सकते ना, तो UTM वाली शेप पर चाहिए.
Here we go. Name of the island. So it has come in. चलिए तो देता तो
वाला देता था.
I'm zooming out, and now I am at this level, and then I have created. I click on this editor and start editing. This start editing is very important. So you press this. You click on the editor and click on start editing. So start editing on this. Continue, and then from here you select the tool. This create feature. This is create feature. Okay. So you can see I'm doing the digitization. Abdul Rahman? See, the polygon has been created. And then you stop editing. And name of the island. Open attribute table and you write down the name. What is the name? Port Qasim, Island 1. Qasim, Island 1. So the name is given, you stop editing, you save the edits, and now if you remove this, you remove this, unhighlight this. See, this is the polygon that you have created. It has an information table. You can change the color. Okay, and label go to new. Go to labels. So everybody is with me?
Yes, yes.
Okay, very good. So the point I'm trying to show you is that you have to practice. The more you practice, the more you will learn. You have to open your software, ArcGIS, create different shape files on your georeference TIFF map, and you create point. Okay.
Can you measure can you measure the area?
No, I will do the. See, now it is the map is being created. This is a vector map. This is a vector map, and you can print it, and you can for calculation of area, we have to use the projected system, not the geographic system, and we will not use the longitude latitude. I can calculate the area on this, but the area will not be correct because this is not a projected system. This is just a global coordinate system, longitude latitude. In longitude latitude, we don't get the correct area because it's not projected. In order to get a projected system, we will do it the same exercise with UTM coordinates. Okay?
Okay.
So I will show you in my next session. I will show you how to do the same exercise with projected system. So then the area will be completely correct. Not many people will tell you. In order to calculate the area, you use the projected system.
I get the point.
This is just for global. We are working in the global coordinate system, and it is not incorporating the curvature of the Earth. The curvature of the Earth is very important, and for that you need to transform that curvature using mathematical transformation. So we use generally in practice, in real world practice, when we are asked to calculate the areas, we use project system. But for general visualization, for Google visualization, you can create a KML file. You can create KML file.
Okay, thank you.
you can create a KML file of this polygon. See, R toolbox, click on R toolbox and create a KML file of this, and you can open it on your Google Earth. So for that you have to use R toolbox. You click on R toolbox. As it's about to get opened. So in our toolbox, you get the toolbox, and then you go to conversion tools, and go to KML. Second. To KML, layer to KML, select layer to KML, click on, and then the KML file will get created. Keep it in the same location, island 1. And that's it. So you will get the KML file. You click on the KML file and you can see the same. Yeah, this is the path. Change color. H2T. So the name of the file, island 1, KML. And it goes in there, it will create. So the layer that we digitize, the polygon that we digitize, got converted Java. Folder दिखा Click on this one. Open with, and you can open with in Google Earth. I don't have Google Earth on my laptop right now. Okay, so we are all done. Everybody in the class?
Yes, yes.
Yes, yes.
So what you have learned today, what you have learned today is assignment. So you have now fairly good idea. You have now fairly good idea. Assignment of coordinates to a scanned map, and then doing the rectification, then creating a polygon rectifier, and then creating a polygon vector shapefile, creating an attribute table, assigning the name of the field, and then converting into a KMZ file, and then you can open it on in Google Earth, and it will hopefully, I'm sure it will open at the right location. You can check it. You can do it. I will try to bring in your local area map. If you guys have any maps of your area, share it with me, and then we develop another exercise for you guys.
Okay.
Right.
Right.
Looks good. Looks good.
Yeah.
Okay, wonderful, wonderful. Any improvement?
Well done, better.
Very good, very good. Yeah, let me. Yeah, but please practice. Please practice.
Yeah. Practice makes perfect, you know. You do more,
Yeah.
you get more, you know.
Yeah, maybe you do something wrong, but that's fine. That's fine. If you do anything wrong, that's fine. You don't lose anything. You create a point file, a point shape file, a polygon shape file, maybe several points. Points are basically the landmarks. You know, the several points, and polyline is basically the road network, the stream network. And then this is the polygon that we gave you, the IDM. And then you create the map. You keep on creating the map, and then while you're doing the digitization, there's a whole lot of exercise in how do you do the digitization. This is very simple digitization that we showed you today, but there's a complicated digitization. हमारा कोई map दिखाना पर पार करेगा वो जो हमने जमा कराई है हमारी रिपोर्ट PDF. I'll show you one map that we created. वो जो जिसमें जैकबाद वगैरह का हम दिख रहे हो ये प्रोफाइल यार इतनी जगह तो मैं जैकबाद के जिसके पॉलीगॉन्स बनाए हैं काट के दे वो दे वाला मत इसमें होगा
ये वाले प्रेजेंटेशन लगा हुआ सर आपने सीएस एचपी हिस्ट्री वर्किंग एक्सट्रा अच्छी बड़ी पड़ी इसको शेयर करो
Yeah.
Okay, this is the slide. This is an area close to your this area map that we are working on this. My name is Babar Sani. This is my presentation. We are doing all this. This is the GIS map, the GIS environment. we are doing the land revenue system, works and services, automation and mapping, and this revenue map. You see, these are the control points.
Yeah.
These are the control points. We overlay the map, the similar map. You can see this is a satellite image, and this is the map, and we have correctly georeferenced it, and we can verify from the features that they are exactly in line. And then we digitize, we create the polygons. Each area is identified, and this is all GIS-based maps. You see, this is an automation, and we have these maps based on this. This is the database, and we have created this. And you can see this is an area master plan. These are the coordinates, and we do all this. This is the master plan. This is the georeferencing. We do the georeferencing. We created this. We industrial zone. This is Port Qasim. Port Qasim area, very close. This is the Karachi Airport. This is the revenue map. We overlay this map, and we digitize this with these coordinates. The control points. These are the control points. Georeferencing. This is the village encroachment. This is the digitized area. This is the runway. This is the length of the runway. This is the area of the runway, area in square kilometers, and then infrastructure mapping. And we do the infrastructure. This is the in our city, some town. These are the administrative boundaries. These are the drains, river, and this is Gujar. And this is the road network that we digitize. This is the sewerage lines that we digitized. This is the water supply lines that we digitized. And then this is the satellite image. And in this satellite image, we have complete overlay of this. And then these are the plots. This is the drainage pattern, the manholes, sewerage system. These are the topography. These are the manholes. You see the manholes. You know what manholes? And these are the plots.
Yes.
These are the sewerage lines, and this is the area, the plotting that we did. And from we connected the drains, and this is the actual work that we did. And these are the sewerage system. We designed, we incorporated all that information. The inner dia. You see, this is the commercial street. This is the diameter, and these are the manholes connectivity. Everything is there. These are the manholes that we digitized, and the information. This is the survey part of a big area, town area. We do the land use, and this is the topographic survey for rainfall. These are the center line points. We calculated the inundation model. So this white is basically in GIS, the elevation. This white is the lower areas where you have rainwater accumulation, and these are the longitudinal and latitudinal transfer slopes in GIS of this road. This is the road. This is the solution. This is at a higher elevation. You can see this is higher elevation, and this goes down. And this is my staff. This is my survey car. This is my this is called DGPS instrument. We put it on the car, and we can complete all this topographic survey. And this is the information that this is the lab, this facility, GIS facility that we started. This is all we have done. This is our lab. These are the scanners, the plotters, and everything. So this is just to give you an idea. These are the maps, scheme maps, and the satellite image digitization. And you see, this is Port Qasim, and this is a big port area. There are only 2 ports in Karachi. This is the Port Qasim area, and we are doing all this. We have done this. We have developed this model, and we know each and every plot and we have done this, and this is online ArcGIS, and you click on this and you get, this is the dashboard that we have created, and this is the training manuals that we have created, 2-day course, 1-day course, GIS training, self-exercises for the Sydney Coastal. This is these are the models that we created. So just to give you an idea, this is a quick run. All right?
Yes, yes.
So,
Very big project, yes, indeed.
So I hope the class, you can see the scope of the work. You can see the scope of the work. There's a lot of work that can be done, and I'll be seeing you soon next week, inshallah. Okay?
You next week.
Okay, bye-bye. Meanwhile, you practice, all right?
Yeah. If I do more practice for this, there will be a reach, yeah?
Yeah, I will, because of the Eid holidays, we may have Eid, we may have Eid on Friday, Thursday and Friday, so we will adjust our class.
Inshallah, we will communicate, inshallah. We will communicate.
Yeah, what we need to give us one or more exercise. Then on the next on the next we can start the advantage, like
I will contact you
how to do such these projects.
I will contact you on Monday, Tuesday. All right? Okay. Assalamu alaikum.
Thank you.
Allah Hafiz.
Assalam.
Thank you.